Everyone, myself is Dr. Pinkesh Sottaria, working as an assistant professor at Department of Chemistry, Bhavans College, Dakur. So today we are going to start a new topic under the Pericyclic chapter for the semester 3, MSc semester 3 students. So in the last lecture we have seen about the cyclodation reaction. In today's lecture we will concentrate on the electrocyclic reaction. Okay, now what is electrocyclic reaction? Now in electrocyclic reaction there is a linear conjugated system. Okay, in linear conjugated system, okay, when pi bonds are form a sigma bonds by the transmission of or by the migration of the electron within the closed loop of interchanging orbital, then it is known as a electrocyclic reaction. Suppose if we are having this type of 1,3-butadiene structure, then what will happen under the thermal and photochemical condition? This bond will migrate over here, this bond will migrate over here. So you can form as a cyclobutene. Now in the next one, suppose if we are having a 135 hexatriene, 135 hexatriene. Now if this bond will migrate over here, this bond will migrate over here, this bond will migrate over here. So at that time what will happen? One new sigma bond is formed here and there is two pi bond that are migrated. Now this pi bond is migrated, this pi bond is migrated, but this will be the new sigma bond. In this case also the new sigma bond will be formed over here. So that is the difference between the electrocyclic reaction and cyclodation reaction. In a addition reaction, cyclodation reaction, there are two types of reactant molecule. They are attaching with each other via supraphysical or intraphysical shift. Now in this reaction, there is no other molecule. It is only a one molecule that are transmitted over one another via interchanging orbital, or what we can say within the closed loop of interchanging orbital. Then it is known as electrocyclic reaction. Now these electrocyclic reactions are reversible also. You can also form reactant to product and product from the reactant. So it is a reversible reaction also. So what we can say, it is a reversible reaction. It can be carried out in a thermal or photochemical condition. It is a stereospecific reaction also. Now let us understand that correlation diagram of 1,3-butadiene as well as the 135 hexatriene. Then it is known as 4n pi system and 4n plus 2 pi system. Before going to that, we have to understand two important notation in electrocyclic reaction. First one, that is con-rotatory rotation, and second one, that is this rotatory rotation, that we have to learn. First of all, let us understand by the con-rotatory rotation. Suppose if we are having this type of P loop, minus plus, here we are having A and B group, here we are having C and D group. What you have to do? Suppose if I rotate in a con-rotation, that means both are in a clockwise or both are in a anti-clockwise, then it is known as con-rotatory rotation. Again, if terminal loop are rotated by the similar direction, whether it is a clockwise or anti-clockwise, then it is known as con-rotatory rotation. Suppose if I want to rotate this thing, then this minus will come out over here and this will come out over here. So in the end you can have this type of P loop. Okay, so here we can have, okay, here we are having a minus sign. So here that is plus sign, minus and plus, whatever the group are there, that is A and B, here there is C and D. This is a clockwise. You can also go for the anti-clockwise, but both the directions should be same. Now what is this rotatory rotation? So for the disk, what you have to do, one will be clockwise and other will be anti-clockwise, that will be disk rotatory rotation. Suppose if I rotate this thing in a clockwise, this should be anti-clockwise. If this should be anti-clockwise, this should be clockwise. So that is the difference between the con and this. In this, both the terminal loop are rotated by the anti-direction or anti-clockwise or clockwise direction. One will be clockwise, other will be anti-clockwise. If other will be anti-clockwise, other will be clockwise. Suppose if I rotate this thing in a clockwise direction, so it will be like this, minus and plus. Then after, if I rotate in anti-clockwise, this will be like this. So this will be anti-clockwise, this will be clockwise. So minus sign will be there and plus sign will be there. Now this will be for the A and B. Now this will be for the D and C. Okay, so that is the difference between these two things. Okay, so here you can see over here both the terminal loop are having opposite direction, then it is known as dis-rotatory rotation. If both terminal loop are in a similar direction, then it is known as con-rotatory rotation. Okay, so now let us understand, it's a theory part. So in the theory part, similar way we will start with our correlation diagram. Okay. Now what is correlation diagram? I have already told in cyclotron injection. In examination they will ask a question like this. Suppose if we are having 1,3-butadiene, they will ask this question like this, 1,3-butadiene. They will say con or dis, thermal or photochemical condition, and it is converted into the cyclobutene. Now explain via correlation diagram. So what you have to explain? First of all, let us understand by its structure. So that is 1,3-butadiene. Now in 1,3-butadiene there are 4 pi electron. Now when it is undergoes thermal photochemical condition, what will happen? This bond will migrate over here, this bond will migrate over here. So one will be formed as a sigma bond and other will migrate. So here we will get a cyclobutene structure. Now this is the for the 1,3-butadiene and this is for the cyclobutene. So what is the difference between that? So here we are having a 4 pi electron, so we can say that there will be 4 wave function, sin 1, sin 2, sin 3 and sin 4. Now sin 1 and sin 2 will remain at the BMO and sin 3 and sin 4 will remain at the ABMO. Here in this structure you can say that there is a pi bond formation and sigma bond formation. So first of all sigma pi, then it will be pi star and it will be sigma star. Okay, so now we have to see the correlation diagram for 1,3-butadiene for the electrocyclic reaction. Now for 1,3-butadiene you have to draw a 2 diagram. First we will draw about the con-rotatory rotation, then after the dis-rotatory rotation. Now let us understand for the con. Okay, so let us start with the con-rotatory rotation. So here I am drawing energy diagram, that is E. Okay, then after sin 1, sin 2, sin 3 and sin 4. Okay, so what I have to do, I have to just put this thing over here. Okay, you have to practice this terminal loop and loop formation by your own. I have one suggestion that you should practice by using a pen, not by the pencil. Some of the students will use a pencil in a what we can say examination, but it is not okay. You should use a pen. Okay. Now we are having 4 pi electron. So for the nodes, what we have to do, n minus 1, 4 minus 1. So there will be 3 nodes for this structure. So here we can put over here nodes, that will be 0, 1, 2 and 3. Now let us start with the minus plus. Minus plus, it is not having any node, so we can put all the minus plus over here. There is one node, so we can put over here, 2 will be this side, 2 will be this side. So minus plus, minus plus, plus minus, plus minus. So there will be 2 node. Okay, so 2 will go over here and 2 will be here. So we can say minus plus, node is there, plus minus, plus minus minus plus. Then after 3 node 1 2 and 3, minus plus plus minus minus plus and plus minus. Okay, after seeing this all this thing, what you have to write down over here, that is sigma, it will be pi, then after pi star, and then after sigma star, this will be your BMO, this will be your ABMO. Now we have to see the 1,3 betadine. First of all, con rotatory rotation. So what you have to do, you just have to see the terminal loop 1 and 4 for all the cases. So I am writing over here con rotatory rotation. So it will be minus plus, okay, minus plus. Here if I change from the clockwise direction, so it will be come over here, so it will be having a plus minus. Here we can see both are having what we can say different sign. So what will happen, it will come at the sigma to pi. Okay, here there is a sigma, it will come under the pi. So whatever the orbital you are having, it is a pi orbital. So in this, what we have to show, we have to just show the pi orbital, not a sigma. Okay, here it is a sigma, but the energy will be increased. Why it is increased? Both the terminal loop are having a different side via using a con rotatory rotation. So here we are having a minus plus sign, so it will come under the pi. So in the pi, what we have to see, suppose if I rotate this thing, so this is the pi structure. So pi orbitals are not changing. What is changing? So this is sigma bond. The new sigma bond is formed. Pi bond is always migrated. So whatever the sign in the pi orbital, we have to fix that sign as it is. Here that is a whatever the sign of minus plus and minus plus, we just have to fix that sign. Here we can put as a minus plus and minus plus. Whatever the sign are there, I just have to copy that sign over here. Second thing, here terminal loop, the minus plus will remain as it is for the quantitative rotation. Here if I want to change, so it will be minus plus. This part you should not write in examination. This is our rough work. Okay, so you have to directly see this over by the rough work. This part should not come in an examination paper. So minus minus, both the signs are similar. So what will happen? The energy will be decreased. It undergoes the pi, so it will undergo the sigma orbital. So here the sigma bond is formed. So we have to show the sigma bond formation. The sigma bond formation, so it will act as a terminal loop. You have to remember sigma bond, terminal loop, pi bond, a middle group. Okay, so here we have to assign the terminal loop over here. So whatever the sign is there, minus minus and plus plus. Okay, so this will remain as a minus minus. Then after sign 3, if I rotate in a clockwise direction, it is also clockwise direction, so minus plus, so it will come under the plus minus. So the energy will be increased because of the sign is different. So it is having a pi star orbital, so it will come under the sigma star. So we have to focus only the sigma bond. For the sigma bond, we have to take as a terminal loop. So what we have to take, minus plus minus plus. Okay, then after, okay, so here we are having a minus plus, then after it will come under the minus plus for the clockwise direction. Both the signs are different. It is having a sigma star orbital, so it will come under the pi star orbital. For the pi star orbital, we have to focus for the middle part, so it will have a plus minus and minus plus. So whatever the sign are there, we have to fix over here. Okay, now looking at this structure, what we have to conclude for this correlation diagram, here we can see that BMO electron will remain at the BMO and ABMO electron will remain at the ABMO. So we can write down over here conclusion part. What is your conclusion? So we can say that from above correlation diagram, we can say that BMO electron will remain at the BMO and ABMO electrons will remain at the ABMO. Thus, it is thermally allowed reaction and photochemically forbidden reaction. Clear? So that you have to conclude. It is not like that in examination they will ask 1,3-butadiene con and dis. They will also ask 1,3-butadiene con also individually and dis also. So whatever the question is given, you have to answer accordingly to the questions and its marks. Okay, so here we have concluded that BMO electron will remain at the BMO and ABM electron will remain at the ABMO. So thus we can say that it is thermally allowed and photochemically forbidden. Okay, now let us understand by the rotatory rotation. Okay, now let us understand the rotatory rotation. So first of all you have to draw this thing, then after the node, that is minus plus minus plus minus plus minus plus, one node is there, minus plus minus plus, change the sign, plus minus plus minus, then after two node, so that is minus plus plus minus plus minus minus plus, then after three node 1 2 and 3, so it will be minus plus plus minus minus plus and plus minus. Now what we have to see, one loop will be clockwise direction and other will be anti-clockwise direction. So here the clockwise direction, whatever the sign is there, we have to fix that sign. So it will be minus plus over here, then after it will have the minus plus. Okay, so both the signs are different. So what we have to see, so we have to fix that sign here. Okay, so it is come under the sigma, so it will undergo the sigma, below the sigma. So what we have to do, here we have to fix the terminal loop in a sigma bond formation. So here I can put over sigma bond formation minus minus plus plus. Okay, now let us understand this thing. One will be minus plus as it is, will remain as it is for the psi 1 up to the psi 4. Then after it will undergo the anti-clockwise. This is clockwise direction, this is anti-clockwise, again this is clockwise direction, this is anti-clockwise direction. So it will clockwise minus plus, it will anti-clockwise, that is plus minus, both the signs are different. So it is having a pi orbital, it will come under the pi star orbital. So for the pi star orbital, the pi bond should be shown over here. So whatever the middle bond is formed, you have to show over here, that is minus plus and that is plus minus. Then after sign 3, so it will come under the minus plus sign, that is clockwise direction, it is anti-clockwise direction, both the signs are different. So minus minus, so it will come under the it is having a pi star orbital, it will come under the pi orbital. So what will happen, you have to show the pi orbital. So that is middle one, that is plus minus and plus minus. Okay, then after sign 4, that is minus plus as it is, that is plus minus. So it will have the greater energy, it is come under the sigma star, so it will goes the above the sigma star orbital. You have to show above the sigma star and below the sigma orbital. So here we are showing the sigma orbital, so we can say that sigma orbital, so it will have a minus plus plus and plus. So here we can see the both the signs are different. Okay, so now from this diagram we can say that conclusion, the BMO cross will be the ABMO and ABMO cross will the BMO. Thus we can say that it is a photochemically allowed reaction, whereas thermally forbidden reaction. So in the conclusion you can say that from above correlation diagram, okay, from above diagram correlation diagram, we can say that okay, that BMO cross ABMO and ABMO is crossing BMO. Thus we can say that it is photochemically allowed reaction and thermally forbidden reaction. So that is our conclusion. Okay, so by that way you can conclude that in a 4n system, for the for the 4n system, what will happen, thermally allowed reaction and photochemically allowed reaction. Okay, for the 4n system, photochemically dis and thermally con. So that you have to remember. In conclusion we will see this thing. Okay, so now let us understand the 4n plus 2 pi system. Okay, so that is the 6 pi system. So in examination they will ask this type of question, that is 1 3 5 hexatrine. Now that is converted into thermal or photochemical condition. Thermal or photochemical condition, that is cyclohexadiene. Okay, so now let us understand by its structure, that is 1,3,5 hexatrine structure. When we are using thermal or photochemical condition, so it will come under, that is pi bond formation and new sigma bond is formation. So that is sigma pi 1 and pi 2. So there are total 6 pi electron. So we can say that there should be 6 wave function: psi 1, psi 2, psi 3, psi 4, psi 5 and psi 6. Psi 1, psi 2, psi 3 will remain at the BMO. Psi 4, psi 5, psi 6 will remain at the ABMO. Total nodes, okay, total nodes, it will be 6 minus 1, it will be 5. Okay, so now after seeing 1,3-betadiene, we have to draw the structure for the correlation diagram for con and dis for the 1,3,5 hexatrine, and we have to conclude that whether this reaction is thermally allowed or photochemically forbidden. Okay, so now let us understand by its correlation diagram. So I will draw this structure correlation diagram first of all. Okay, so I have drawn over here, that is a sigma 1, sigma 2 up to sigma 6, then after BMO, ABMO, then after sigma, pi 1, pi 2, pi 1 star, pi 2 star and sigma star. Then after what we have to see the nodes 0, 1, 2, 3, 4 and 5. Okay, now after showing the nodes, we have to put the nodes over here, that is minus plus, minus plus, minus plus, minus plus, minus plus, minus plus, one node. So it will be minus plus. So here we are having minus plus, minus plus, plus minus, plus minus, plus minus. Then after two node, so what we have to see the two node, so we have to conclude the two node over here. So 2, 2, so it will come over at 2 here, 2 here. So we can say that the minus plus, minus plus, plus minus, plus minus, minus plus, minus plus. Then after 3 node, so what we have to see 1, 2 and 3, 2 from this side, 2 from this side, 2 from this side. So that will be minus plus, plus minus, plus minus, minus plus, minus plus and plus minus. Then after 4 node 1, 2, 3 and 4, there is only one possibility for this. So minus plus, plus minus, minus plus, plus minus, okay, minus plus, plus minus, minus plus, plus minus, minus plus, then after plus minus. Okay, you have to check this thing. So it will be not having any node, so I have to rub this. Okay, now 5 node 1, 2, 3, 4 and 5, so it will minus plus, it will be plus minus, minus plus, plus minus, minus plus, plus minus. Then after we have to see the connotation. So what will happen over here? So let us start with here sign 1. So minus plus will remain as it is for the each thing because of the connotation. So I can put over here minus plus for all the sign. Okay, so we just have to rotate the connotation by the minus plus sign. Then after it will come under the plus minus, so it will have a plus minus. Both the signs are different, so what we can say, the energy will be increasing. It is having a sigma orbital, so what we have to see, it will come under the pi 1 orbital. Now this pi 1 orbital, there are two pi bonds are there in the structure, so it will come under the this pi 1 and pi 2. So there is two loop over here, two loop over here, terminal loop that is for the sigma. Okay, so what we have to see, terminal loop that is for the sigma, and for the pi there are these four loop will be there. So what I have to see, I have to just copy this for loop as it is. Okay, whatever the sign are there, so it is having a minus plus sign for the all this thing, loop minus plus, minus plus, minus plus and minus plus, so it will remain as it is. Okay, then after here we are having a minus plus and plus sign. Okay, so what we have to see, so here minus plus, so clockwise direction, so it will always come at the clockwise direction, it will minus plus. Okay, if I rotate from this side, both the side, okay, so it will come as the minus plus. So both the signs are similar, whatever the energy is there, it will decrease. It is come under the pi 1 orbital, so it will goes down to the sigma orbital. So here sigma bond formation is there. So what I have to just copy, I have to just copy for the sigma bond formation. Okay, let me correct. Okay, so it will come under the sigma, so it will decrease this energy. Now let us understand this one. This is clockwise, this is also clockwise, so which is having a plus minus, both the signs are different. Now it is having a pi 2 orbital, so it will goes down to the pi 1 star. Okay, so whatever the signs are there, we just have to copy that sign, this 4 orbital for the pi star orbital. So I have to just copy this sign over here. So first of all, let us draw the p orbital over here, that is a minus plus sign, that is plus minus, it will plus minus, it is having a minus plus. The 4 energy, whatever the energies are there and whatever the sign is there, it will remain as it is. And then after this thing, okay, it will undergoes the clockwise direction, it is also clockwise direction, so minus plus and minus minus. So both the energy, both the signs are similar, so the energy will be decreased. It is having a pi 1 star orbital, so it will goes down to the pi 2 orbital. So what we have to see, we just have to copy this thing. Some of the students will copy this side to the this side. Okay, so you have to remember, whatever the increasing decreasing side, you just have to copy that sign only. Okay, so now let us try from here. So it will have a plus minus over here. So this is a plus minus over here, it is having a minus plus and a minus plus. uh, Here you can see that the both whatever the sign is there, I just have copied this thing from here. Okay, so pi 1 star, it come under the pi 2. Now next thing, that is for the clockwise direction from this side, and this clockwise direction from this side, both the signs are different, so we can say it will goes to the pi 2 star to the sigma star orbital. So what we have to copy, we have to see the terminal loop, okay, for the sigma orbital. So here we can say the minus plus sign, so it will minus plus sign, plus and minus. Now here in this case, so it will have a minus plus and it will have a minus minus, okay, minus plus. So both the signs are similar, so whatever the energy is there, we have to just drop down that energy. So it is having a sigma star orbital, so it will come under the pi star orbital, pi 2 star orbital. So what I have to copy, I have to just copy the 4 orbital, that is 1, 2, 3 and 4. So here we can say that plus minus, here we can say minus plus, what we are plus minus and minus plus. Okay, from this diagram we can say that BMO is crossing ABMO and ABMO is crossing BMO, thus it is a photochemically allowed reaction and thermally forbidden reaction. After drawing this diagram, you have to just conclude that from above correlation diagram, okay, from above correlation diagram, we can say that BMO electron travels to the ABMO and ABMO electron travels to the BMO. So we can say that it is a photochemically allowed reaction and thermally forbidden reaction. One is allowed, so automatically other is a forbidden reaction. The photochemical allowed reaction and thermally forbidden reaction. So this is for the quantitative rotation. Okay. Okay, so now this is the diagram for the this rotation. So I have just seen over here whatever the graph we have seen in our previous slide, that is quantitative rotation. You just have to reverse that thing. Let us understand by its a thing. Suppose if we are having a this rotation, what we have to calculate. So here we can see that here we can say that the BMO electron will remain at the BMO and ABM electron will remain at the ABMO. I just quickly revise this thing over here. So here we are having both the signs are similar. It will have a sigma, so it will come under the below the sigma. Here both the signs are the what we can say the similar. So here whatever the sign is there, it will remain at the sigma star, sigma 1. so it will come under the sigma. Okay, so here the energy will be decreasing. Whatever the sign here, plus and minus, the energy will be increasing. Here we are having a sigma 2, so it will come under the pi star orbital. Okay, so by that way, whatever the graph is there over here for the connotation, you just have to reverse. Suppose if you are getting minus plus over here, so for the D's you just have to see it will have a minus minus sign, so the energy will be decreasing. Okay, so by your own you can calculate for the D's rotary rotation. So it is your homework. You have to find out for the 135 hexatriene 135 hexatriene for the D's rotary rotation, whether it is thermally allowed or photochemically allowed reaction. Okay, via doing a cyclohexadiene, that is your product. Okay, so this will be your homework. You have to just find out, you have to just write down the correlation diagram. Now after seeing this all this thing, you have to write down the conclusion part of the correlation diagram. What is the conclusion part? So here we can write down thermally allowed, here we can write down a photochemically allowed reaction, here we can write down a 4n system and 4n plus 2 pi system. Okay, 4n plus 2 pi electron system. So for the 4n system, the thermally allowed will be the con, photochemical allowed will be this, 4n plus 2, the photochemical thermally allowed will be this, and photochemical allowed will be con. So this will be your conclusion part of this all reaction. In examination they will ask directly whether this 4n system thermally allowed or photochemical allowed. You just have to remember that. They will also ask what will be the photochemically forbidden. Okay, for the 4n and 4n plus 2 pi electron, if it is having a photochemically allowed, thus it will have be a thermally forbidden reaction. Thermally forbidden reaction. Okay, so by that way you can conclude your conclusion via correlation diagram. This is the most important 4 question for the quantitative and rotatory rotation via electrocyclic reaction under the pericyclic chapter. Okay, thank you for watching it. Next time we will see about the sigmatropic reaction.